Okay, so welcome back to day 4. Today we're going to be continuing on our journey through R and data analysis and web apps in RShiny. So today we won't be building upon any of the apps that we've been making before, but instead we'll transition back into mastering some more fundamentals of R and using those skills to apply to analyzing data. So I'm going to share my screen. Okay, so here you see the screen here. If you're following along, you can follow along using the template code or the complete version of the code here. Okay, so the first thing we're going to do is we're going to create our own data set similar to one we made last time. So I just made a list of names and I put them in a vector called names. And I made, I wrote in their corresponding ages here in a vector called ages, and I wrote their corresponding favorite colors in a vector called colors. So now I'm going to be reviewing some data structures and introducing a new one relevant to data analysis. Okay, so for analyzing this information here, we want to be able to put it into a table format or some sort of consolidated format so that we can easily access data and match it to other information in the data. Okay, so there's multiple ways we can combine this data into R into different data structures. So what we learned from last time is we can combine all this data into a matrix. So we can bind the columns together using cbind. And we just bind together the vectors of information. Oops. And we get this matrix here. We can also combine this information by feeding it into the matrix function, which takes a vector of all the values in one vector. So we combine those first in a vector. And then we specify the number of rows, which is 5, the number of columns, which is 3. Okay, and then now we see here that we have the same matrix. Okay, so one problem we might run into when we're consolidating all this data into a matrix is that we notice that a matrix can only contain data of one type. So we noticed that we had character strings with representing the names, and then we also had their ages represented by numbers. But since matrices can only have one type of data, these numbers actually got converted into character strings. And also in general, matrices aren't the standard way to be storing data and analyzing data. So let's try to combine this data into another way that's more suitable for analyzing. Okay, so what we can also do is combine this information into a list by feeding in each corresponding vectors into the list, names, ages, and colors. And now we see this list printed out here into the console, where each list element represents a different piece of information about all the people represented here. The first element is names, the second element is their ages, and the third element is their colors. If we want to, we can specify the names of the list, remember using the names function. We have to first assign it to a variable, And then we say list, the name's a list. We can say names, ages, and colors. Okay, and now we're going to print out this. Okay, and now we see the corresponding information in the list specified by the description. But note that, so this is a slight improvement from matrices because all the data that was transferred into this list is still keeps its original data type so that we can have different types of data into this list. So under the names element, we have character strings. Under the ages, we have numbers, and so on. But notice that the data formatted into the list is also still not suitable for data analysis because now we can't really access data in multiple dimensions. For example, we can't match up the names to the ages and to the favorite colors specifically, so that when we're analyzing data, we can't really match up these elements to each other. Okay, so we saw that combining data into a list and a matrix, they each have different problems, but that's why when you combine these two types of data structures into a new one called a data frame, we bypass both of these problems and make the data suitable for analyzing data. Okay, so to make a data frame, we're going to first assign it to a variable. We're going to call the function data.frame. And inside data.frame, we're going to put the vectors as columns of the data table. And now we're going to print out the data frame. And we see this data frame printed right here. Okay, so what a data frame is, it's essentially just a data table. And it looks like a matrix, except it's formatted more like a data table in that it has column headers, and you can have different types of data in the table. Okay. We can also create a data frame from scratch by putting all the elements into the data frame originally. So I'm going to create the same data from scratch. So I'm going to say data2 is a data.frame, and then I'm going to put in all this data here. So when we're passing in parameters to this data frame function, there will be a lot of arguments, and it might get too long to fit on one line. So what I'm going to do is split it onto multiple lines, and when R compiles this line, it reads the whole line as one. So it's okay that this function spans multiple lines. Okay, so in this data frame that we're instantiating by hand, we first specify the row names. So we can say row names equals student 1, student 2, student 3, student 4, and student 5. And then right after, we specify all the columns that we want. So here, we can specify the names, which I'm going to copy from the top here, the names right here. And then I'm going to copy in the ages. Okay, so actually what you might notice is slightly different from how we're instantiating the vectors first. You might be curious as to why I'm setting an equal sign and also putting commas after each line. So when we're specifying these vectors of information into the data frame, um, we're not actually creating these vectors independently on their own. We're passing these vectors as parameters into the data frame, and each of these parameters specifies a column. So we're specifying first the row names equals this list of row names, and then we're creating each column as a parameter into the data frame. And now when we run this, we can preview the data by printing it out here, and we get the same result. Okay, so that's how to create a data frame. Now we're going to run some operations on this data frame, which are essential to analyzing data. Okay, so first thing we want to do is access information in this data frame. So what I'm going to do is I'm going to preview the data frame here, print it out on the console, and say we want to get the whole first row. So we can access information in a data frame similar to how we do in a matrix. So I'm going to first show you how to access specific elements in here. So we access it like a matrix. First, you find the row and the column number, and you access it by putting the row number and the column number into square brackets. So I'm going to type the name of the data frame, and then in square brackets, we want row 1, column 1. So I just write row 1, column 1. And that should print out Alice. Great. Okay, if we want the whole row, we type the name of the data frame, and then in square brackets, we want the whole first row, and then we want the whole row, so we don't specify a column number, and that prints out the whole row. Similar to a column, if you want to print out the whole column, we're going to access it by typing the name of the data frame example, and then specifying the row and the column number in square brackets. But we want all the values in column 1, so we're not going to specify row number, we're just going to specify column number. Okay, great. And also you can access multiple rows or multiple columns using the same way. So in the square brackets, we want to specify the row numbers and the column numbers. So the row numbers we're going to specify are 1 and 2, repeated into as a vector. And then we want all the column values, so we're going to leave that blank. And now we see that this line of code accesses the first and second rows of the data frame. Okay, and now similar to a list, you can create names for the data frame, the rows and columns of the data frame, and access elements in the data frame by using their row and column names. Okay, so first what we're going to do is preview the data frame. And then notice that the column names were automatically instantiated when we were automatically added when we instantiated this data frame earlier. So we only need to specify row names. And I'm going to specify the row names here again as student 1, student 2, student 3, student 4, student 5. And the function for doing that is row names, and you put the name of the data frame that you want to change. Okay, so when we do that, we just change it. For row names, voila, it's right here. So now when we access this data, we can use the row and the column names. Okay, so I'm going to go here, and we're going to access this in a similar way as we did above right here, but instead of specifying the specific row name and the specific column name, we're going to replace those numbers with the names of the rows and columns themselves. Okay, so first, let's see, data frame example. So instead of 1 comma, we're going to actually put the name of row 1, which in this case is student 1. And that returns the row named student 1. Okay, if we're going to access the first 2 rows, we're going to do the same thing as we did above, but instead of specifying row 1 and 2, we're going to actually specify the names of the rows that represent 1 and 2, which in this case is student 1 and student 2. Okay. Now, if we want to access the whole column, we're going to do the same thing as we did up here and go to data frame example. But instead of specifying the first column by the number 1, we're going to replace it by its actual column name, which in this case is names. And it returns a vector of all the elements under the first column. And you get the point to access a specific element. We're going to specify by its row name, student 1, comma, names. Okay, great. So another way we can do it is by using the $sign. So what I'm going to do is type in the name of the data frame and then access the column by its column name, by first writing the $sign and then the column name. And that prints out all the values that are under the column that's named names. So what this does is this returns a vector of all the names. So we want to access a specific name in the vector. We copy that right here. We want to access a specific name in this vector. We can access it one-dimensionally. So we want Alice's name. Alice's name is the first element in this vector. So we're just type 1. So we're combining the accessing notation with the $signs and the square brackets. Okay. Okay, but say we wanted to access, let's preview the information in this data frame again. But say we wanted to access the information not by the row names or the column names or the rows and columns, but by the actual information that's inside the data table. For example, say we want the all the names of the students that are 15 years old, right? We could see here clearly that the students that are 15 correspond to student 2 and student 3. So we can access that information by specifying those specific row names. But in general, if we had a data set that contains like thousands of student data, it would be inefficient to access this information by hard coding in the specific row names. So what we want to do is subset this data subject to certain conditions. And our condition right here is age of 15. So to do that, now I'm going to cover how to, I'm going to cover what conditional statements are and how they're processed through R. Okay, so R has several conditional operators that allow you to evaluate conditional statements. And conditional statements and operators, those sound like fancy names, but they're quite intuitive in everyday English language. And I'm sure you've encountered these if you studied other programming languages, such as Python, Java, and well, every computer language has conditional statements. Okay, so what a conditional operator is, or, and, or not, and they're used to. Now we're going to apply them on conditional statements. So statements are either true. For example, 0 is less than 1. That is always a true statement. So when we run this line, it returns value true. A statement can be false. So 0 equals 1. This is always false. So when we run this line, it returns the value false. Notice that the syntax for specifying for testing if two values are equal is the double equal signs in comparison to the single equal sign or the assignment operator, which assigns a value on the right to the left, which I'm sure you've seen in other programming languages. So now, how are conditional statements used? So if we pass in a conditional statement, like if 0 equals 1 into an if statement, it runs some certain lines of code within the curly braces subject to this condition. So I want to say this is true, else print this is false. Okay, so this if statement, of course, is going to print true because this condition is always true. If we had a false condition, this if statement would print false, right? Because this condition is false. Okay, so now what if we had multiple conditions that we wanted to subject to? So what if we say 0 is less than 1 or 0 is equal to 1? So the OR operator in R is specified by a single long bar, which is not, it's different, it's a different character from 1, I, or L, or any of those characters. It's the long bar on the side of your keyboard. So this splits the two conditional statements and returns a single Boolean value, true or false. Okay, so the best way to explain this is by just saying out loud what the condition is. So we go through this logic of the statement. If 0 is less than 1,
Lucas, you might be muted.
okay, sorry. Is the screen being shared?
Yeah, I think you're good now.
Okay. Did I cut out?
I think you froze for a bit, but it's all good.
Oh, okay. Okay. Is the meeting being recorded? Yeah. Okay. Cool. Sorry about that. Okay, so we're gonna pick up right where we left off. I was saying with conditional statements, if we say it out loud, if 0 is less than 1 or 0 is equal to 1, print this is true. Otherwise, print this is false. And one of these conditional statements is true. So the OR operator returns true if either one of these statements is true. Compare this to the AND operator. Compare this to the AND operator, where if we say if 0 is less than 1 and 0 equals 1, print this is true, else print this is false. And this conditional statement prints out false. And if we say this out logically, if 0 is less than 1 and 0 equals 1, print this is true. And obviously, in English, we know that statement is false because the only way AND operator returns true is if both statements are true. And one of these is false, which means the whole thing combined with the AND is false and returns false. Okay, and the last operator we have is not, which reverses the logical statement. So we had 0 is less than 1 is true. Not 0 equals 1 would be false. 0 equals 1 is false. So not equals 0, 1 is true. Or we can write here 0 is not equal to 1, which is true. Okay, great. Okay, so now we're going to subset this data that we had before, subject to some conditions. Specifically now, I want to say, give me the students who are 15 years old. Okay, so we're going to use a subset function. And within the subset function, first we specify the data that we're drawing from. And then next, we're going to specify the condition that we want to set. And in this case, we want the ages to equal 15. And this returns the two students whose ages are 15. And we can be a little more specific about this. If we don't want all the students' information whose age is 15, and we just want specific information, like we just want the names of the students whose ages are 15, we can specify that in subset. So instead of subsetting the whole data, we can just specify the names. And that just returns the names of the students. We're subsetting the names of the students whose corresponding ages are 15. Okay, another function you can use to subset data like this is the function which. So which just takes in one argument that we're going to use, which is a condition. So say the condition we want is data frame ages equals 15. And what this returns is a set of values for which this condition is met. So in this case, if we look at this data, rows 2 and 3 satisfy the condition that the ages are 15. So it returns the values 2 and 3. And why is this useful? Well, if we can access information in the data right here. Now we can access them using specific rows, which is a bit subtle. But instead of, we can access this information by specifying the specific rows 2 and 3. But if we don't want to hard code in 2 and 3, we can replace this by this line of code, and it gives the same information. Okay, the last function that we can use to analyze data in this way is the unique function, and it does exactly what it sounds like. So unique, this takes in some data that you want to pass in, and it returns a unique list of all the unique values of that column. So in this case, the unique ages are 14, 15, 16, 17, and that's what this unique function returns. Okay, so now we're going to apply these principles on a real big data set. So here today, I found this COVID data set on a publicly available website that shows information about coronavirus cases between March and July. Okay, so the data file I sent you is in a CSV format. CSV stands for comma separated values, which means all the elements in the data table are written in text file separated by commas. And we want to load that file into our environment as a variable so that we can start accessing elements in there. So what we want to do is read the CSV file, which is specified by this function here, the name of the file, and then I'll pass it to a variable called, I'm going to call this COVID data. Okay, so the one common mistake that might happen is that if this data doesn't load into R, most likely it's because you haven't set your working directory properly. So you might wonder, how does R know where to find this COVID dataset file that's stored locally on your computer? So what you have is a working directory. So this when you downloaded this file, it probably automatically stored this file into your downloads file, into your downloads folder on your computer. So what you have to do is go to Session, Set Working Directory, choose Directory, and choose the folder in which the data set is contained. So here we see that this CSV file is in my desktop. So I'm going to set the working directory as my whole desktop. Okay, and now it reads in the file, and it reads in the CSV file and converts all the elements into a variable called COVID data. Okay, so now if we want to look at this data, we can print it out into the console. But notice that this data is pretty big. It will not fit into the console. So there are other functions for summarizing the data inside the console. So first thing you can do to take a look at this data is go to your environment here and click on COVID data. And it opens up this table format suitable for users looking at the data. So what we notice is that the columns specify specific criteria such as day, month, year, cases, death, country, territory code, population, continent, etc. And each row corresponds to an observation that represents all the cases and deaths for one specific day. Okay, so let's go out of this window. So what we can do to preview this video, this data is we can run the function view, which just does what I did before. We can also run the function head, which prints out the first 6 values, first 6 observations into the console. We can run tail, which displays the last 6 elements in this data table. We can do str. Str stands for structure, and this just shows the structure of the data table. So here are the columns, and here's a preview of the values that correspond to these columns. We can also provide summary, which is actually quite useful. A summary provides a comprehensive summary of many different statistics, actually all these statistics for each column. So for example, for cases, it tells you the mean number of cases, which in this case is negative 2,461 for some reason. That's weird, but it gives you the max cases, the mean cases, and the certain quartiles or quantiles of all the observations under cases. Okay, and we can also find the number of rows. This shows that there are 33,477 observations that were taken, and the number of columns. There are 12 different data metrics that were measured. So now let's apply the principles that I just applied to a smaller data set up top to this coronavirus data set by subsetting certain data to answer these following questions. Okay, so here I have a set of questions I'm going to try and answer using these data analysis techniques. Okay, so the first question I'm going to answer is how many total COVID deaths have there been in Asia? So when you get used to this type of thinking, you can find the answer to this question by typing one line of code, but I'm going to deconstruct it for the purpose of showing you my thinking process. Okay, so first of all, which data do we want to look at? We're looking at all the observations in the COVID data. Specifically, we want to turn our attention to a subset of this data, specifically to those observations where the continent is Asia. So I'm going to create an object called Asia. And to this object, I'm going to create a subset of the original COVID data. And I'm going to subject it to the condition that COVID data, I believe it's called continent exp equals Asia. And now here we have a new object, new data frame called Asia, which is a subset of all this COVID data. So we preview it. We notice it displays the exact same information as COVID data, but it only displays that where the observations correspond to places in Asia. Okay, and then what we want is to look at are all the observations under deaths, and we want to take the sum of that. So all we're going to do is take the sum of Asia deaths. And there are 95,490 coronavirus deaths in Asia as of August 1st. Okay, and as I said, we can do this all in one line. So when we're subsetting this data, we actually don't need the whole data. For example, we don't need to know the day, month, and year that these happen. All we need to know is that the continent is Asia and what the deaths are. So we can just subset the deaths. I'm going to print this out. So this prints out the deaths for the observations in which the observation happened in a place in Asia. And now we don't even need to store it as a variable. We can sum up all this data directly. And we arrive at the same answer, 95,490. Okay, next question. How many days has the US reported more than 10,000 cases? So first, let's think about which data we want to observe. So we want to look at COVID data, but specifically we want to turn our attention to that observations in which the cases are greater than 10,000 and in which the place is US. So what we're going to do is I'm going to create an object called USA 10,000, and I'm going to create a subset of the whole COVID data. And our condition is that the cases is greater than 10,000 and that the countries and territories, I believe it's United States of America separated by underscores. Okay, so now we go over to the environment and click the data frame that we just created, and notice that this data frame contains all the observations in which the cases are over 10,000. And the countries and territories is called the United States of America. Okay, so now what do we want to do with this information? It says we want to find how many days has the US reported over 10,000 cases. Okay, so all these data refer to observations in which the cases are over 10,000 and the countries in the US. So all we want to do is find the number of observations. So the number of rows, each row corresponds to an observation. So the number of rows corresponds to the number of observations, which is 130. And as I said before, we can find this information all using one line of code. And now this statement says, give me the number of rows of a subset of the coronavirus cases data where the following conditions are met. The cases are over 10,000 and the countries in the US. So that's that. And the last question we're going to answer is, what is the median population of the countries that have ever reported over 2020 cases? Okay, so first, what data are we restricting ourselves to? So we want to look at all the data of over 2020 cases. We're going to subset that data, subset the whole coronavirus data where the number of cases is greater than 2020. And we go over here, we can look at this data frame, and we notice that this data frame contains rows which correspond to observations in which the number of cases was over 2020. Okay, great. Now what we want to do is find the median population of the countries that have reported these 2020 cases. So actually, we're not quite done. Subsetting this data. So actually, what we want is not the whole data. We just want the population of the observations in this. So if we look at pop data 2019, this column refers to the population of all the observations in which the cases were over 2020. And we want to find the median population of all the countries that correspond to these observations. So we don't want to find the median of all the possible populations. We want to find the median of the list of populations that qualified this, satisfy this criteria. So we want the unique list of, find the unique list of populations. And then we want to find the median of that. So this finds the median population of countries that have reported observations in which the number of cases was greater than 2020. And with any data analysis, the answer might seem quite arbitrary. In this case, 50 million. It's hard to know if we were correct. So let's try to confirm our result by seeing which country this refers to and checking if this country has ever reported over 2020 cases. Okay, so what we want to do is find the name of the country in which the population was this number. So first we want to find a subset of all the countries and territories where the population data was equal to this number. And as we can see, we get an overwhelming number of observations that says Colombia. We only want the name of this. We don't want all the names corresponding to the observations, so we can say unique. We just want a unique list. We get Colombia. So now we want to view the data of just Colombia. So we're going to subset the whole data where COVID data in countries and territories equals Colombia. And then we're just going to view this. And here we see a data frame corresponding to all the observations that were taken in Colombia. And as we confirm, Colombia has recorded over 2,020 cases on a single day. In fact, many days. So that checks out. Okay, so that's it for data analysis.